Alright, so welcome to Academic Digest class. Today I'll be teaching you binomial theorem. Remember in our last class we stopped here when we did 1 minus 2, anything raised to power 1. And we did it, we analyzed it. When it's raised to power 1, the coefficients will be 1 and 1, 2 terms, 1 and 1. So notice that I will now have 1, then minus 2, 1, minus 2. Then the coefficient will be decreasing for the first term and increasing for the second term. By the time you do it, you have 1 minus 2, 2 terms. Alright, let's go. Let's go right here for binomial theorem. We use binomial theorem when Pascal's triangle can no longer help us. Because Pascal's triangle can only work for positive powers. A situation where I have 1 all over 5th root of 1 minus x. So let's say as I have this now, they say we should solve the binomial theorem. Notice that this is the sentence saying, using indices, this is 1 over. 5th root is the sentence saying 1 minus x raised to power 1 over 5. And for the fact that it's having negative power, this is the sentence saying x, sorry, what am I doing? 1, this is the sentence saying 1 minus x raised to power. Whenever 1 is the numerator, it means negative power, minus 1 over 5. Check my video on the 9 laws of indices. So what we are going to expand is this. Notice there is a negative power. And whenever it's negative power or fraction, we can use Pascal's triangle. Pascal's triangle only accounts for whole numbers and positive numbers, positive whole numbers. So once it's fraction or negative, we must use binomial theorem. And before I start giving you the formula for binomial theorem, there's something we call formula for the nth term of a binomial theorem. And this formula for nth term of a binomial theorem, mathematics is sweet. If you are serious, you will see as we progress, even with regards to our mathematical induction that we've not treated. So I said, this formula is given by simply saying, remember that anything binomial theorem has to do with combination method. So it's simply saying n combination r. That is getting r from n. That is from a term or from the whole given term multiplied by, remember that binomial expansion has to do with a and b, 2 terms. So multiply by a. And anytime you have r here, you just do a will be raised to power n minus r. Whatever you have, assuming is 0, n minus 0. Assuming is 1, n minus 1 for a. Then b will always be this r. So b raised to power r. I use multiplication in order not to confuse it when we have x. So that's why I use dot for my multiplication. So this is the formula for nth term of a binomial theorem. Let's say, for example, in this question, where we have, that we treated last, where we have y plus 2 raised to power 2. Let's say they ask us to find the second term. They just tell us find the second term of this. I'll just use n combination r times e raised to power n minus r times b raised to power r. And you need to know that r, this r is given by the formula given term minus 1. So anytime they ask you to find, just minus it by 1. If they tell me to find the second term, r will simply be equals to, if they say find the second term for first term, r will be equals to given term, which is 1 for first term, minus 1. So r is 0 for first term. Then for second term, r will simply be, second term means 2. So 2 minus 1 will be 1. So for second term, r is 1. You need to know for the third term. For third term, r will simply be 3 minus 1, which is equals to 2. And so you need to know this formula. And that means that you need to know that for the last term, let's say they tell you to find the last term. Anything last term, always know that if they tell you find the last term of, just know that r will be equals to the given power. That is what you just need to know. So r will be equals to the given power. What do I mean? See here. See right here. Let's say I have this 1, 2. That is when n is 2. And they say the last term, that I should find the last term. Notice that r now will be here. See, 1, 2, 3. The third term, that is 3 minus 2, is going to be equals to this power, which is 2. Let's come to this when I'm giving power to be 3. Notice that if the power is 3, I will have how many terms? 1, 2, 3, 4. 4 terms. And that means that the last term is the last term is 4. So 4 minus 1 will be equals to that given power, which is 3. Let's say I'm having when n is 4, the power is 4, and I want to find r. Notice that the total term I will have when the power is 4 is 5 terms. 1, 2, 3, 4, 5. So the last term will be 5. 5 minus 1 will be equals to the power 4. So that means that whenever they ask you, question tells you, find the last term of so, just use r to be equals to the power, which is n. Or you simply check if the question that they gave you is given, let's say they gave you 5 as the power. So you simply remember that if 5 is the power, that the number of terms that you will have will be 6 terms. So if you know that it's going to be 6 terms, remember when we started binomial expansion, that was done, you simply do r now will be the term, that is the last term, 6 minus 1, which is equals to 5, and this is equals to the n. Alright, so if I know this, let's try to see if it works for this. Then we'll go back to binomial theorem. So you see that this is going to be n combination r, and n here is 2. N is 2. A is the first term, B is the second term. So I'll simply do 2 combination, and in this case, we are finding the second term, combination 1, dot A here is y, then raised to power 2 minus 1, then dot B is raised to power r, which is 1. So, and 2 combination 1, let's try to solve 2 combination 1, see what it will give us. 2 combination 1, anything combination, first of all, n combination r is equals to n factorial all over, or you say permutation over r factorial. Let's go this way. N factorial minus n minus r factorial, then r factorial. Alright, once I know this, what it means is that I'll simply substitute for what n is. N is 2 factorial here, and 2 factorial is the same thing as 2 times 1, but let's leave it at the factorial. All over 2, n is 2, 2 minus 1 factorial, and r is 1 factorial. And we know that factorial talks about that function that multiplies itself with numbers below or behind it. Or we can actually say that it talks about the given positions that a particular number occupy before you get to that particular number. Alright, so if I know this is going to be the same thing as saying 2 factorial all over 1 factorial, 1 factorial. Notice that this is now the same thing as saying 1 factorial is 1. So 2 divided by 1. 2 times 1 is 2. So this is simply 2. So I'll bring it out. Everything I have here is just 2. Then remember that B is 2. That is 2 raised to power 1. So this is going to be dot y raised to power 1 dot 2. Anything raised to power 1 is that thing. So you see that we are left with 2 times y. Y raised to power 1 is y times 2, which is 4y. And notice that that's our second term here. So you need to know that. So now that you know this, let's now find, this is the formula for nth term of a binomial theorem. So if they tell you find the 5th term, find the 7th term. Now let's now you get the formula for binomial theorem. So the formula for binomial theorem is very simple. It's simply remembering that from these accounts, when we have terms, we always have when we have 0, 1, and 2. That is when the power is raised to power 2. When it's raised to power 3, we have 0, 1, 2, 3. So our power, raising of power, always starts from 0. So that means that for binomial theorem, the formula for binomial theorem, I don't care what you see on textbooks, because they normally make it so complex. And I've been able to go through all that, and I find a simple way of going about it, which is the same thing. In some textbook, you see this n combination r to be the same thing as they come and put something like this. They write n, they write r. Is the same thing. All right. So now this is not the formula. I'm just trying to illustrate something. So the formula is simply given by n combination 0. N combination 0 dot, that is times a raised to power n minus 0 times b raised to power 0 plus, that is for the first term. This is for first term. First term plus the second term. The second term will always be, remember I told you that r in the second term is 2 minus 1, which is 1. So second term will be n combination 1 times a raised to power n minus 1 times b raised to power 1. So the third term, this is for second term. So for the third term, it will be third term arrow here. Notice that it's almost as if it's the same thing with that formula for nth term. So notice that it's almost as if. So but this time around, when we talk about third term, we remember that arrow will drop. Arrow will become 3 minus 1. It will be 2. So the third term is simply n combination 2 times a will raise to power n minus that arrow, which is 2. Then b will carry that r, which is 2. So notice that it's almost as if that for each term, a is subtracting that term. That is, a is subtracting, the r, while b is carrying the r. So this is for third term. And this can go on plus, this can go on to infinity, to any given n terms. Or you say n combination r dot a raised to power n minus r. Okay, let's do it here. Dot plus n. It will go on to n combination r dot a raised to power n minus r dot b raised to power r. So it progresses, it goes on. So you need to know this formula. And why you need to know this formula is that, notice that for when the powers are positive, it's as if it's increasing. But once it's negative, once the power is negative or a fraction, we are no longer checking if it's increasing. Rather, what we are checking is to just use this formula and maybe solve for first 3 terms, or maybe solve for first 2 terms, or maybe solve for first 4 terms. So when it's negative power or positive power, we are not checking if it's increasing again. But we know that if it's 3 power 3, which is positive, the terms will be 4. If it's power 2, the terms will be 3. So, but when it is negative or a fraction, we are no longer checking for the increase. Rather, what we are checking is, what did the question ask us to find? Is it to find the first 3 terms, or to find the first 4 terms? Or can we just say, since it's so thing, let's find for the 3, let's expand it to just 3 terms, or let's expand it to just 4 terms. My neighbor, a friend, or a student, the person sitting beside me, can expand his to 4. Another can expand to 2. Another can expand to 3. But if the question tells me find the first 4 terms, once it's negative power or fraction, I simply make use of this formula and go on to that number of terms. So you can see that this is first term, this is second term, this is third term. If they say find the first 3 terms, I just use this. If they say find the first 4 terms, that means I'm supposed to go on to getting n combination 3 times a raised to power n minus 3 times b raised to power 3. It is very simple. All right. So if I know that, let's try to solve this question this problem that we've created here. So 1 minus x raised to power minus 1 over 5. So all I will simply do is to use this formula. So I will expand my own to just 3 terms. But don't limit yourself to where we stop. When I solve just for 3 terms, you can go on to solve for, like, let's say the first 10 terms. Since it's negative power, there is no negative or fraction, there is no limitation to the number of terms you can get. That is the point I'm trying to make. It's not like the positive, where you know that the number of terms the power determines the number of terms. But once it's negative or fraction, nothing limits you from getting as many terms as possible, because it runs to infinity, which we don't know. That is why in most textbooks or in most understanding, they tell you that combination has no negative combination. There's nothing like negative combination or negative permutation. So once it's in that negative, you are free to go as much as you can. All right, so let's try to solve this. I have 1 minus x raised to power minus 1 over 5. That's what I have there. All right. So you need to, in this case, you need to have that idea, that understanding that the first term is a, the second term is b, and the n is a negative n, which is minus 1 over 5. And your r, you remember that r remains given term. R is equals to given term minus 1. But here we are not going to be looking at r. Rather, we are using our formula, which is n combination 0 dot e raised to power n minus 0 dot b raised to power 0. Then plus the second term. It's 3 terms I want to find. Plus n combination 1 dot e raised to power n minus 1 dot b raised to power 1. Plus n combination 2 dot e raised to power n minus 2 dot b raised to power 2. So you can go on to solve the third term. That's your assignment. N combination 3 dot e raised to power n minus 3 dot b raised to power 3. Alright, I notice most time I'm trying to be fast to beat time, and it makes me, should I say, forget to include certain things. So this time around, let's be slow a bit. Combination 0, n minus 0. Okay, so you are solving this one as your assignment for me. You will find me the fourth term. I'm going to find first, second, and third. You find me the fourth term. So notice that since I'm finding the first 3 terms, let's go. N combination 0. Here, n is minus. Remember that n combination r is the same thing as saying n factorial over n minus r factorial r factorial. Alright, so that means that n combination 0. Here, n is minus 1 over... okay, I think let me do this thing outside. Let me be doing this outside so that I'll bring back the answer after. So, n combination 0. Let me find n combination 0 first. If I find n combination 0, I come back and find e raised to power n minus 0. Then come back and find b raised to power 0. Then multiply. So, n combination 0 is going to be the same thing as saying n here is minus 1 over 5. All over, using this formula, it will be minus 1 over 5 minus r there is 0. Then factorial, then 0 factorial. So this is going to give me the sentence as saying anything minus 0 is that thing. So if I have minus 1 over 5 minus 0 is simply minus 1 over 5. And you know that this is in factorial, this is in factorial, this is in factorial, this is in factorial. 0 factorial is 1. And I have no use for it because anything times 1 is that thing. So remember that 2 divided by 2 is 1. 3 divided by 3 is 1. So everything I have here is the same thing with what I have here. So they can cancel each other out to give me 1. So in most first cases when you are doing this, the first case is always 1. Reason being that why is always 1 is that remember here when we did this our Pascal's triangle, what we have here in the beginning will always be 1. So in the beginning it will always be 1. In the beginning, if you remember, the coefficient of the first term will always be 1. And what this combination is giving us, these things that we have here, obviously you're seeing n combination. This thing, what it will always give us for the first, in the first term, the coefficient will always be 1. That's what I'm trying to get. In the first term, the coefficient will always be 1. Get that? So even if I want, I won't be solving for n combination 0. I just be doing it as 1. So I've gotten 1. Let me come and put it. I just got 1. I have 1. Dot, if you like, don't see it. Dot A here is 1. And this is raised to power minus 1 over 5. Then minus 0. Then dot B here is minus x. And it is raised to power should be minus 0, raised to power 0. Remember, this is where we are looking at. All right, so notice plus. So notice that any 1 raised to anything, even 1 raised to 1 million is still 1. So once I see 1 raised to anything, no arguments, it's just 1. Then anything raised to power 0, remember that this is minus x, not x. Anything raised to power 0, minus 2 raised to power 0 is 1. Minus 1 million raised to power 0 is 1. So it's positive 1, so times 1. So everything in the first term is just 1. So I put my plus and wait for the next action. All right, let's go to the second term. For the second term, let's try to solve. And the second term, what was there? The starting is n combination 1. So let's solve for n combination 1. Then come back, solve for e raised to power m. That is 1 raised to power n minus 1. Then minus x raised to power 1. So remember, let's go. N combination 1 is going to be, in this case, n is minus 1 over 5 factorial all over minus 1 over 5 minus 1 factorial, then 1 factorial. And this is going to give me the sentence as saying, using LCM, I can get this to be minus 1 over 5 factorial all over minus 1 over 5 minus 1. And anything standing on its own is over 1. Like my student said, the student said we can do this to be the sentence as saying minus 1 over 5 minus 5 over 5, so that the LCM we have here is simply the sentence as 5. So that this becomes minus 1 minus 5, which is the sentence as saying minus 6 over 5. Okay, if this is confusing, let's use this to check it. This is over 1. So I know that the LCM here is going to be definitely 5. 5 into this will be minus 1. 1 times minus 1. Then come here and times. It will be 5. 5 times minus 1. That is 5 divided by 1 is 5. Times minus 1, it becomes minus 5. And this is the same thing as saying minus 6 over 5, which is the same thing. So, but most of the time we don't use it because of trying to be careful, but it's the same thing. So we now have all over minus 6 over 5. Should be? Yes. Then we have minus 1 over 5 up here. And a bit starting. Then, okay, we have 1. Remember, we have 1 factorial. So this is factorial, then 1 factorial. But anything 1, I don't normally make use of it. So I can just say, let this get out. So I just cancel it out. So notice that this now becomes, remember what I told you in class. I told you in class to always pay attention to when you have A over B divided by C. That it is not the same thing with when I have A divided by B over C. Remember I told you that. So in this case, what I have here is simply minus 1 over 5 divided by minus 6 over 5. And this is the sentence as saying minus 1 over 5 times 5 over minus 6. This will take care of this. This will take care of this. So I am left with 1 over 6. All right. So let me go and put it. So the combination, n combination 1 in this case will simply be 1 over 6 times A here is 1 raised to power minus 1 over 5 minus 1. I don't care what, since it's 1, I don't care what it's kind of, times minus x raised to power 1. Let me bring my plus sign down. So if I check this, it's now going to be the sentence as saying 1 over 6 times 1 times anything raised to power 1 minus x. So automatically it will influence the whole answer. So the plus I have here will change to, this will become minus 1. That is when you times this through, it will become minus 1 times x, which is minus x over 6. So let me put it, the first term is 1. This will become minus x over 6. So let's move to this part, the third term. Let's move to the third term. And the third term I have there, n combination 2. So let's move to the third term. So for third term, n combination 2. N combination 2, please. Okay, just pay attention there. N combination 2 will simply be the same thing as saying minus 1 over 5 factorial all over minus 1 over 5 minus 2 factorial 2 factorial. Now notice that this up here, do you remember that? Please remember that n factorial is the same thing as saying n factorial. That function that multiplies itself with numbers below it, n minus 1, n minus 2, n minus 3. What do I mean? If I have, we are done with this. If I have 5 factorial, for example, or 3 factorial, for example, this is the same thing as saying 3 times 2 times 1. And this is the same thing as saying 3 minus 1, 3 minus 2. So the same principle is what we are using here. So for that reason, we just have to have this stored knowledge. That's why you learn. When you learn, you have that stored knowledge that helps your reasoning. Which is why they say experience is the best teacher. Alright, so I will now have n combination 2 to be equals to minus 1 over 5. That is the factorial. I'm trying to get this so that I don't stress myself doing this. That's one thing you can do. Inside this I have n minus 1. And inside this I have n minus 2. Are you seeing it? And remember that everything I have here is n minus 2. So let me replace it. This is the same thing as saying minus 1 over 5 minus 1. Then this is the same thing as saying minus 1 over 5 minus 2. All over minus 1 over 5 minus 2. Then 2 factorial, 2 factorial, factorial. Remember, I stopped here because I am seeing this. I can go on with this. So I want everything here to cancel everything here. That is the essence of doing this. Remember, if I have, for example, 3 factorial and I have over 2 factorial, I can go on by saying 3 times 2 factorial all over 2 factorial, so that this will take care of this. That is just what I did here. So I just did minus 1 factorial. I did it. It's essentially saying minus 1 over 5 minus 1. Minus 1 over 5 minus 2. So I've done it. So I now simply get minus 1 over 5 into minus 1 over 5 minus 1 all over 2. And remember, we've done this before. And this gave us minus 1 over 5 into, when we did it here, it gave us this. Give us minus 6 over 5. So this gave us minus 6 over 5 all over 2. So if I know this, I can see that this is fraction up here being divided by a number. So this is going to be minus times minus becomes plus. So it's going to be 5 times 5 over 25. So 6 over 25, that is n combination 2. n combination 2 is going to be the same thing as saying, or you say minus 1 over 5 combination 2. So you don't get confused. N here is minus 1 over 5. So 6 over 25, that is times over 25. Then it is being divided by 2. So let me just put that division here, so you don't confuse it. Divided by 2. So this is the same thing as saying 2 over 1. So this is now going to be the same thing as saying 6 over 25 times 1 over 2, which is the same thing as saying 6 over 50. Are you seeing it? 6 over 50. So if I get this 6 over 50, let me carry it. I've gotten 6 over 50. And it's a positive one. So I'll just come and put, for n combination 2, 6 over 50. Then remember that a here is times 1 raised to power minus 1 over 5 minus 2. Then times minus x, and this is carrying 2 here. So you are the one solving this one for me. So 2. So this is going to be the same thing as saying 6 over 50 times 1. 1 raised to anything is 1 times 1. Then this is dots. Notice that this is minus x squared. And for example, if I have minus 3 squared, is the same thing as saying 9 positive. So minus x squared is the same thing as saying minus x times minus x, which is the same thing as saying plus x squared. So you need to always note this. So I will simply now have x squared. So when you do this together, you now have 6x squared over 50. Let's check. Something can go here. 2 can go here to give me 3. 2 can go here to give me 25. Are you seeing it? So I have plus 3x squared over 25. So if you notice, it's almost as if the it is increasing. X is increasing because it's the second term. So the second term is always increasing. Assuming this is another x, you see that the power will be dropping. So that's why it's disappearing. So you see x here, x here. The next one you solve will still have x cubed. It will be progressing so far as it's the second term. So there you have it for today. In our next class, we'll look into multinomials. We'll look into how to go about solving multinomials. But I believe with this, if you remember our steps, how I went about everything, you should be good to go. Okay, so your assignment is to solve this for me. Assignment, this one, we solved it in class. So if you are not in class, solve this. We did 1 over cube root of 1 minus x. So this is your first assignment. So the second one I want you to do for me is get me the 3 over 7th root of x squared plus y, all raised to power 1 over 2. So this is your assignment. Expand. Teacher will solve the hard one. Teacher giving the simple one. So expand this for me. Thank you. Remember to subscribe. Thank you.